So looking at number 1, I'm going to go into second matrix. And now there are 3 columns: names, math, and edit. Let's go over to edit and hit enter on A. Oops, I pushed too many buttons. So I hit edit on A, and it's going to ask me how big the matrix is. Well, this equation has 2 rows and 3 columns, so it's going to be a 2 by 3. And this only works if the x's are lined up and the y's are lined up and the answers are lined up. So you can see here that there are 3 perfect columns. In order to use your matrix, they have to be set up this way. Okay? So I'm going to enter the coefficients, 2, 3, and 18. 1, -5, and -17. Okay? So now I'm going to ask the calculator to do what is called reduced row echelon form, RREF. And there is a button that says REF, and REF will not do what we want it to do. Well, sometimes it will, but REF sometimes works, and RREF always works. So you need to make sure that you exit out. If I push RREF right now, it's going to replace this -17 with RREF. So push second, quit, and go back into matrix, second matrix, then go over to math, and RREF is close to the bottom. So I'm going to go up from the bottom. You following along over there? So RREF, and it asks what matrix do you want to use. So I need to go back in a 3rd time, second matrix, and I want to hit enter on A for names. Enter, and I get this: 1, 0, 3, 0, 1, 4. So you need to write down that matrix. And now to interpret the matrix, the first column is the x column, and then the y column, and then the answer column. So the top row is telling me 1x plus 0y equals 3, or x equals 3. For the second one, y equals 4, and I'm done. So these 2 lines intersect at 3, 4. Okay? All right. So let's do the second one. Go back into matrix. Oops. Second matrix, go over to edit. And this one is a 2 by 3. 2, 1, 7. 3, -2, -7. Exit out. Go back into matrix. And let's do math. Oops. Man, got the fat fingers going on today. So math, and I want RREF. Second matrix A. And I get the matrix 1, 0, 1, 0, 1, 5. So what are my answers? X equals 1 and x equals 5. Y equals 5. So in order to get it correct, you need to write both the matrix and the answers. Now, there's a little bit more I want to tell you, but I want you to practice this a little bit. So I'm going to pause the video and go ahead and start working on the stuff on the first page. Okay, so hopefully you've been checking your answers and they're going well. What if I had a function or a system that looked like this? What if I had 4x plus 2y equals 8, and 2x plus y equals 4. What do you notice about that system? I could divide the top by 2, and it would be same as the bottom, so we should expect infinite solutions. So let's plug these in. So second matrix, go over to edit, 2 by 3, 4, 2, and 8, 2, 1, and 4. So I'm going to exit out. And I do RREF, and I get 1.5 and 2 and 0, 0, 0. So far, every problem you've done, you've seen this pattern, 1, 0, 0, 1. And then you have some x value answer and some y value answer. Yeah. If you see this pattern, then the lines touch once. Okay? If you get something else, like this, I do not have that pattern, but if I look at the bottom row, it's 0x plus 0y equals 0. And when does 0 equal 0? Always. So in this case, bottom row with all zeros, then the answer is infinite solutions. Let me go back into my matrix, and I'm going to change, let's change that first 8 to a 4. Now what should I expect? What is the answer to this system if I change that value? And the opposite of infinite is no solutions. So I exit out, do my RREF, and now I have 1.50001. Do I have this pattern here? No. So I look at the bottom row, and I have 0 plus 0 equals 0. When is that true? In my world, never. 0 plus 0 equals 1. Oh, sorry. 0 plus 0 equals 1, which is never true. So this one is no solutions. So if you end up with a bottom row of all zeros, infinite solutions. If you end up with 0, 0, 1, no solutions. Okay? Look at number 9. Something's missing on number 9. There's no y value. So I plug in a 0 in its place. So the bottom row would be 4, 0, 8. Okay? Turn to the last page. Now for 17, I have 3 equations. A linear equation of 3 variables is the graph of a plane. So here are 3 planes. Now usually when you graph 3 planes, they intersect at a single point. Sometimes you'll have infinite and sometimes you'll have no solutions. So go into your matrix. Go over to edit. How big is this matrix? 3 by 4. So 3, enter, 4, enter. So then I put in 1, 1, 1, 6, 2, 1, negative 4, negative 15, 5, negative 3, 1, and negative 10. Then I do RREF. And have you noticed I haven't actually been typing in RREF anymore? Well, if the last thing you did was RREF, all you have to do is hit equals, and it will recalculate it with the new matrix. You should just be able to push enter and it will work. Now, if whatever you entered last was like 6 plus 2, then you got to go back in and find RREF. So, I have 1, 0, 0, negative 1, 0, 1, 0, 3, 0, 0, 1, 4. Do I have the one solution pattern? Yes. So my answers are x equals negative 1, y equals 3, and z equals 4. Okay. Look at the last one. How are you going to do number 22? Every time a variable is missing, put a 0 in its place. Well, some funny things can happen with 3 equations. You could get this, where we have 2 rows of something and then 0, 0, 0, 0. That would mean infinite solutions. Okay, that was pretty easy. What about bottom row 0, 0, 0, 1? No solutions. But it is possible to have 0, 0, 0, 1, and then 0, 0, 0, 0. So, is this infinite solutions or no solutions? Infinitely no solutions, no. Well, let's think about it. What does this tell us about the 3 planes? Well, we have 3 planes. If I have a row of infinity, that means 2 planes are exactly the same. Right? And what about this plane? It doesn't touch it. So imagine the floor is a plane and the carpet on the floor is the same plane, right? So we have 2 of the same planes, and then we also have the ceiling. So 2 planes are identical and 1 plane is parallel. So the answer would be no solution, because where do all 3 planes touch? Nowhere. And the one solution is really easy to see. If we pick the floor as one plane and this front wall as another plane and that side wall as another plane, how many times do all 3 planes touch? Once, right in the bottom corner. Okay? So with planes, it's a little bit tricky. If you have no solution and infinite solution at the same time, no solution always wins, because 2 identical planes and 1 parallel plane never intersect. Right? Go for it. Good luck.